Today's video is on systems of inequalities. We show the solution to a system of linear inequalities by graphing them. This process is easier if we put the inequalities into slope-intercept form. Slope-intercept form is y equals mx plus b. Remember, m is the slope of the line, and b is the y-intercept of the line, or where the line crosses the y-axis. Now remember, your first step would be to graph the lines using the y-intercept and slope. And remember that if the inequality is less than or greater than, you make the lines dotted, because the points on the line do not make the inequality true. Now, if the inequality is less than or equal to, or greater than or equal to, you make the lines solid, because the points on the lines are part of the solutions. Now, you need to remember that the solution also includes points not on the line, because these are inequalities. So you need to shade the region of the graph. You shade above the line for y greater than or y greater than or equal to. And you shade below the line for y less than or y less than or equal to. I will now show you an example of how to solve a system of linear inequalities. So the first thing we need to do is put these equations in slope-intercept form. So starting with the first one, 3x plus 4y is greater than negative 4. Well, first thing we have to do is, to get the 4y by itself, we are going to have to subtract 3x. So remember, anytime you bring something over the equal to sign or an inequality sign, you change the sign. So we got to subtract 3x from both sides. So we get a negative 3x minus 4. Then, to get rid of the 4 that's being multiplied to y, we divide everything by 4. So now we have y by itself, y greater than. We have negative 3/4 x, and then a negative 4 divided by 4 is minus 1. Alright, so this is the first one in slope-intercept form. Then the second one, x plus 2y is less than 2. Alright, first thing we have to do, we're going to get the y by itself, so we're going to have to subtract this x from both sides. So we're going to take it over to the other side, so it becomes a negative x plus 2. And then we're going to divide everything by 2 to get rid of the 2 times y. So now we have y by itself, y is less than. Remember, there's an understood 1, so that is negative 1/2 x. 2 divided by 2 is 1. So here is the second equation in slope-intercept form. Now let's graph our two inequalities on the same coordinate plane. Notice in the first one, our slope is negative 3/4, and our y-intercept is negative 1. So we start at our y-intercept because we know this line crosses the y at negative 1. Our slope is negative 3/4, so that means, since it's rise over run, we're going to go down 3, since it's negative, and over 4. Now remember, we can do the same thing in the other direction. We can go up 3 and left 4, and it is still a negative 3/4 slope. Now, since it is just greater than, it's not or equal to, we put a dotted line to show that the points on the line do not make this inequality true. And since it is greater than, all the y's are greater than, we know all the points above this line are solutions to this inequality. So I am going to put arrows to show that I need to shade above this line. Now, second inequality, our slope is negative 1/2, y-intercept is 1. So this time we put a point at 1 on the y because we know our line crosses the y at 1. And our slope is negative 1/2. So we go down 1 over 2. Or you can go in the other direction. You could go up 1, left 2, because that's still a negative 1/2 slope. You draw. Now notice this is also a dotted line to show that it is just less than. It's not or equal to. So the points on this line do not make this inequality true, because it makes it where it's y equal to negative 1/2 x plus 1. Now, since it is less than, it's all the y's that are below the line. So we shade below the line. Now, if you notice where your shadings overlap, where you see the blue and the red, where the shadings overlap is actually the solution to the system. And so you shade in that area to show that all the points in this area are the solutions to the system. These are the points that make both inequalities true. So if we chose any point in this shaded area here, it would make both those inequalities true. Let's do another example. This will be an example of a system of 3 inequalities. And if you look at the first one, x is less than 4, notice there is no y in that problem, so it's not in slope-intercept form. And that is because we have no slope. This means x is less than 4. All right, so we have to draw a vertical line. And notice I am going to draw a dotted vertical line at 4. This is how you would graph x equals 4. Now it is less than 4, so that means all the numbers to the left of 4, because remember on the number line, all numbers less than 4 are to the left of 4. Right? And then our second equation, y is greater than or equal to negative 1. Since you have no x, your slope is 0. So this is a horizontal line because y is always greater than or equal to negative 1. And notice I am going to put a full line this time because of the or equal to. And it is greater than, so that means we are going to shade above. So notice we are to the left of this blue line and we are above the red line. So we're in that area to the left. All right, now we look at the third line and notice it is not in slope-intercept form, so we have to get that y by itself. So the first thing, we have an x, so we need to bring it over to the other side. So we're going to subtract x. So it becomes a negative x minus 3. We divide everything by a negative 3 to get rid of that negative 3 times the y. And if you remember from previous math courses, whenever you divide or multiply by a negative number, your inequality sign flips over. So this problem becomes y greater than or equal to, notice we have a negative 1 divided by a negative 3, so that becomes a positive 1/3 x, and then a negative 3 divided by a negative 3 is a plus 1. So we are going to graph y is greater than or equal to 1/3 x plus 1. So our y-intercept is 1, so we are going to put a point there to show it crosses the y at 1, and then up 1 over 3, because our slope is 1/3, so up 1 over 3. And remember, we can go down 1, left 3. We put a full line through there, and it is a greater than problem, so that means we are going to shade above this line. All right, so it gets a little confusing here, but we got to shade where they overlap. Alright, so remember, it is to the left of this blue line. Alright, to the left of this blue line. It's above the purple and above the red. So it is all the points in this area, right in here to the left of the blue. So all this area right here, any point that is chosen in this shaded area would make all three of those inequalities true. This is the end of the video on solving systems of inequalities. And so let's not forget to complete your WSQ in your spiral notebooks.